Here is our problem statement. Calculate the design compressive load for a column made up of ISHB 350 at 710.2 Newton per meter and 3.5 meter high. The column is restrained in direction and position at both the ends. Use steel of grade Fa410. So here some initial data has been given. It has to resist some load that we don't know, correct? So we have to use specifically this particular section. Now we just have to find out what is the compressive load taken by this particular section. So this is Indian standard high beam. So it is a rolled steel section. For this, Fy is 250 Newton per mm square. Fu is given as 410 Newton per mm square, and Young's modulus is 2 into 10 raised to 5 Newton per mm square. Now, from table 11 of IS 800 2007, now here the end condition is given as both end restrained columns, correct? It means both ends of the column are fixed. So you need to refer the last category of the table 11. Let us go to that particular table. Here, if you see, both ends are restrained. Okay, when both ends are restrained, then your effective length should be 0.65 times L. So this value will be for effective length. So let us take this particular effective length for calculating slenderness ratio. So for ISHB 350 at 710.2 Newton per meter, now you go to steel table. In steel table, these are the geometrical properties given. Overall depth is 350 mm. Then width of flange is 250 mm. Then thickness of flange 11.6 mm. Area is 9221 mm square. Once you note down all the geometrical properties of the section from steel table, now you go for calculating this ratio. H by BF is equal to H is 350, width of flange 250. So 350 by 250 is 1.4 and thickness of flange is less than 40 mm. So we have taken this ratio H by BF and we have also compared thickness of flange. Based on the classification, section classification, what we can write is according to table 10 IS 800 2007, it falls under buckling class B for buckling about ZZ axis and under class C for buckling about YY axis. So there are two categories we are getting. One is class B, another is class C. Okay, so exactly which class to be considered? So from steel table, now you find out what is radius of gyration. It will be R minimum. There will be two radii of gyration given in the steel table. One will be RX6, another will be RYY. So out of these two, you consider the minimum value of the two. Usually RYY is minimum. RYY is minimum. So that is 52.2 mm. Okay. So that is substituted here in the equation of FCC, pi square E by KL by R bracket square. So E is 2 into 10 raised to 5. KL effective length we have already calculated 2275 upon R is 52.2. So we are getting FCC as 1039.22 Newton per mm square. Now, non-dimensional effective slenderness ratio. This equation is already given in IS code. We have to find out what is lambda value. So lambda comes to be 0.49. FCC value we have just evaluated in the previous step. It is here. And Fy is 250 Newton per mm square constant. Okay. Now for buckling class B, alpha is 0.34, which is imperfection factor. If you remember, we have already noted these values here. For buckling class B, 0.34. Okay. So we are now calculating this term phi, which comes to be 0.669. You need to either remember this equation or need to know where this equation is given in the IS code. So it must be around table 10, table 11, and so on. Okay. So we just refer the IS code also. So phi comes to be 0.669, and our calculated design stress, design compressive stress using this equation is 202.11 Newton per mm square. So strength of column will be compressive stress FCD into area. So area is 9221 into stress is 202.11 upon 1000 converted into kilonewton. It comes to be 1863.69 kilonewton. So this is ultimate load. You divide this by 1.5, you will get working load. So for the given section, the capacity comes to be 1242.46 kilonewton. Now, just one point to mention, either B class or C class to be selected. So for such cases, you consider B class. It is the worst possible thing. Class B will be should be considered. Okay. So when there is comparison, you select higher class. So when there is confusion that one according to one classification section is under B category and according to another criteria section is under C category, then you consider upper class. Okay, A, then B, then C, and then D. This is usually followed. Okay, so this is how we evaluate the design compressive stress of compression members. In next session, we shall start with design examples of compression members. How to design a compression member. Okay.